Hello everyone, I'm Dr. Prajwalit Shikha and today I'm here to talk about different control technologies for accessing a medium. When two users communicate with each other, then for communication they need to have a communication link between them. That communication link is sometimes called as a channel. Now if a single channel can be used by more than two users, then this is called as multiple access. Hence, multiple access is a technique in which a single channel can be shared by multiple users. Now there are basically three kinds of multiple access technologies and they are FDMA, TDMA and CDMA. We'll talk in short about FDMA and TDMA and in detail about CDMA technology. Let us first talk about FDMA technology and how multiple users can share the same channel using this technology. FDMA stands for Frequency Division Multiple Access. So here the whole channel is divided in multiple frequencies. This technique has started in first generation of mobile communication and it is analog in nature. Suppose there are total 5 users which tries to communicate with other 5 users on the other end of a channel. Then how this works? Suppose the channel has been allocated a frequency spectrum in which it has to communicate. Then the whole frequency spectrum or the whole bandwidth is subdivided into smaller bandwidths and each bandwidth is given to each of the users. So hence here there are total 5 users, hence total frequency spectrum is subdivided into 5 different parts and each part is given to each of the users. So here F1 is for first user, F2 is for second user, F3 is for third user and so on. So hence here in a single channel all the users can communicate with other users on the other end of the channel using different frequency spectrum. Now between each two frequency there is a set of frequencies which is called as guard band. Now guard band helps different frequencies to not mix with each other. So hence interference among different frequencies are prevented using guard bands. So this is FDMA technology. Now we will talk about TDMA, which is time division multiple access. This technology is for digital data and it has started in second generation mobile communication system. For example, GSM technologies. Now in this case what happens? The whole channel is divided in different time slots. So let me explain you. If this is a single time in which the data has to be transmitted and multiple users are trying to access the channel, and suppose there are total 3 users which are using the same channel, then how they can use the same channel and communicate. So here what happens, that as I told you that the time is divided into different frames. So here there are, as you can see, that there are 2 frames of 6 microsecond each. Now each frame is further subdivided into number of users who wants to use the channel. So in this case there are total 3 users, hence this particular frame is subdivided into 3 different parts. So 3 different slots. It means that the 6 microsecond is further divided into 3 parts. Hence each time slot is of 2 microsecond each. Now how this works? So whenever a communication is happening using TDMA technology, then what happens? The first frame is passed first. Now when the first frame is passing, then in that particular frame which is of 6 microsecond, first 2 microseconds, the data from first source is passing. Then in the next 2 microseconds, second source data is passing, and in the third 2 microseconds, the third source data is allowed to pass. Now as the first frame time has elapsed, then in the second frame again the same process continues. And this way the channel is shared on time basis. So this is TDMA. Now next very important technology is CDMA, which is Code Division Multiple Access. Now this is a very important feature which started in second generation mobile communication system and is continued in third generation mobile system as well. So as I told you, it is digital in nature. Now what happens in this case? Now here multiple users can communicate with each other using the same bandwidth and in the same time. So there is no frequency division, there is no time difference in the communication among different users. So this is really fascinating. So how it works? So in this case, all the data is first encoded using certain chip sequence. So let me explain you. The formula for that is that the encoded signal which is getting transmitted is equal to or is derived by multiplying the original data into chip sequence. Now what is this chip sequence? Chip sequence can be of 4 bits, it can be of 8 bits or so on. This chip sequence actually encode the data. Now here there is an example that I have written over here, and from this it will become more clear to you. Now as you can see that there are total 4 different sources. As I told you that CDMA is digital in nature. So all the 4 sources are trying to send their data, and the data is in the form of binary. So bits are getting transmitted. So at particular instant of time, source 1 is sending the binary data which is 0, source 2 is sending 1, source 3 is sending 0, and source 4 is sending data which is 1. Now in CDMA technology, the equivalent CDMA code for 0 is -1 and for 1 it is +1. Now the chip sequence is always different for different sources. So there are total 4 different sources here. The chip sequence is of 4 bits and is different for all these 4 sources. Now for first source, the chip sequence is +1, +1, +1, +1. For second source, it is +1, -1, +1, -1. For third source, it is +1, +1, -1, -1. And for fourth source, it is +1, -1, -1, +1. Now, what is the first step in this case? So, as I told you that 0 is represented as -1 in this. Now, in the next step, this -1 is multiplied with the chip sequence bits. So, here, this -1 is multiplied with first +1. So, we get -1 into +1 as -1. Then -1 into next +1 is -1. And -1 into +1 is -1 and -1. So, we have -1, -1, -1, -1 as the data, as the output from this. Similarly, for second source, the data input is 1 and the equivalent CDMA code for this 1 here is +1, and the chip sequence which is different for second source which is in 4 bits, which is +1, -1, +1, -1. Now, the next step is to multiply these two. So, after multiplying, how the multiplication will be done? So, +1 into first bit, +1, it is +1. Then +1 into second bit, which is -1, we have -1. +1 into third bit, +1, +1. +1 into last bit, which is -1, here it is -1. So, similarly, we get these codes. Now, after this, all the codes which have been generated from the chip sequence multiplication, we need to add all these. Now, how addition is done? So, all the first bits are first added from all the sources. So, first bits are -1 +1, -1 +1, which is 0. Then -1, -1, -1, -1, which is -4. Then -1 +1 +1 -1, which is 0. And -1 -1 +1 +1, which is 0. So this is the CDMA encoded data which travels through a single channel. So this whole process occurs at the sender's end or transmitting end. So this is the part of transmitter or transmitting end process is this. Now look here, what happens at the receiving end and how this encoded data is decoded. So this is the data which when occurs at the receiving end, then for each of the sources again, this is the first source, second, third and fourth source. So for first source, the chip sequence remains the same. So +1, +1, +1, +1. Here also for first source, it is +1, +1, +1, +1. Now this encoded data is now multiplied with the chip sequence for first source. So what is the result of multiplication? It is 0, -4, 0, 0. So how it is multiplied? So 0 into +1, 0, -4 into +1, -4, 0 into +1, 0, 0 into +1, 0. The next similar procedure is done for the rest of the sources. Now after this we get these 4 sets of data. Now here in the first set we have 0, -4, 0, 0. Now in the next step we have to add all these bits. So the resultant is -4 in this case, here +4, -4 and +4. And in the next step this result has to be divided by the number of bits in the chip sequence. So here the chip sequence comprises of 4 bits. So this result has to be divided by 4. So after dividing -4 by 4, the result is -1. Here it is +1, here it is -1 and then +1. Now we need to write down what is the encoded, what is the decoded actually bit for -1. As I told you that here -1 is the equivalent code for 0, +1 is for 1. Hence this -1 is actually 0, +1 is 1, -1 is 0, +1 is 1. So as you can see that here 0, 0, 1, 1, 0, 0 and 1, 1 has been obtained. So this is the whole process in which data can be communicated using CDMA technology. I hope this video is useful for you. Thank you for watching.